So this is for BC again, but this time we're focusing on elimination. So substitution and elimination are both algebraic ways of solving, and then we learned the way to solve it by graphing. So this is our third and final way for solving systems of equations. Remember, a system of equation is just two or more equations that you're solving for x, y. So they're on the same graph, or we're using substitution, elimination. So first thing I have for you, just kind of think about, says given this system, why can you not use substitution? So the reason we can't use substitution here is because there's not a variable already alone. So there's no like x equals something or y equals something. Both of them are full equations. So there's nothing to like plug into another one. So in that case, we want to see, can we use elimination? So I have some steps here. First thing you have to think about is, can you cancel a variable? So what that means is if I were to look at these and I were to line them up, does anything cancel out if I were to like add up and down? So I want to look at this negative 3x, and what's right below it is the 7x. If I add those together, would it become 0? No. So let's try the other one. What about negative y and a positive y? If I were to add those together, would that become 0? Yes, it would. So if you have something that if you can add up and down and it will become 0, that tells me that I can use elimination. So if that happens, we're going to go ahead and do that adding up and down. So negative 3x and 7x becomes 4x. And since this becomes 0, they're basically just canceling out. So I am just not going to write anything, and I'm just going to put equals because those are gone. And then 8 plus negative 12 would give me negative 4. And now I'm going to continue solving this, so I have a number for x. So x would be equal to negative 1. So just like last time, you want your answer to be an x and y point, always. So right now I have my x is negative 1, but I don't know what my y is yet. So let's figure out what our y is. And we can find our y the same way that we did before. So I'm going to take this negative 1, and again, you can choose either one you want to put it into. So I'm going to just do the first one. So I have negative 3x minus y equals 8. So what I'm going to do is I'm going to take this, and I'm going to put it in place of that x. So that will give me negative 3, and then times negative 1. So that's going in place of my x, minus y equals 8. And now I just need to solve this. So then I have 3 minus y equals 8. Subtract the 3. Negative y equals 5. And then if you remember, we can't have a negative variable. You can't have negative x or negative y. So I'm going to divide both sides by negative 1 so that my y is actually negative 5. So then up here in my answer, I'm going to put the negative 5 for the y. So the first thing that we did here was decide if we could cancel. So number 1 was right here. And then we haven't gotten to steps 2 and 3 yet. That's if you can't cancel it, which is what we're going to learn next year. So then we added straight up and down to get this. And we solved for that singular variable. And then we plugged in that variable to either equation. And we did that over here. And then we have our final answer. So now we're going to talk about steps 2 and 3. If you can't cancel something, so if not, we're going to talk about that down here. So looking at this, x and 2x, if I add those together, I get 3x, so I don't get 0. And then 3y and 2y, if I add those together, I get 5y. So neither of those come out to be 0. So I'm going to read my next step, number 2 here. It says, if not, choose one you want to cancel. So technically we get to pick. Do I want to cancel out the x's or do I want to cancel out the y's? To be able to do that, you have to multiply the whole equation by a number that you need to get them to cancel out. And that's a little bit confusing. So basically, I want to force something to cancel out. So let's say I want to cancel out my x's. The only way for these to become 0 would be if they were either both 1 or if they were both 2, like a positive 1, a negative 1, a positive 2, and a negative 2. So if this is a positive 2x, I want to think, how can I get this to become negative 2x so that when I add them, they become 0? So erase that. So what can I multiply x by to make it become negative 2x? Negative 2. So what I'm going to do is I'm going to take negative 2 and I'm going to multiply it by this equation. However, you can't just randomly multiply a letter. You have to do the whole thing if you're going to do that. So technically I'm going to multiply this by the x, by the 3y, and by the 7 because you can't just pick and choose. So if I do that, I'm going to get negative 2x and then minus 6y and then equals negative 14. So that's my new first equation. I'm going to go ahead and rewrite my second equation. 2x plus 2y equals 6. Now let's try it. So negative 2x and 2x, does that become 0? Yes, it does. And then you can look over here. This one still won't become 0. So I will get rid of those. I'm going to go ahead and add negative 6y plus 2y to get negative 4y. And now I'm adding negative 14 and 6, so that's negative 8. I'll divide by negative 4. So my y is 2. Now we're doing the same steps that are above. So I added straight up and down. I solved for a single variable. And now I'm going to plug it back into one of the equations at the top. I would recommend that you plug it into the equation that you did not change, because if you accidentally multiplied incorrectly, then everything you're doing from here on out is wrong, and I can give you some more points if I can see your process is correct, but you just made a small mistake above. So I'm going to plug this in to the 2x plus 2y equals 6, just so I don't accidentally mess something up if I plug it into the negative 2x minus 6y equals negative 14,1. So this 2 will go right here for the y. So I have 2x plus 2 times 2 equals 6. I'm just going to solve this down for x. So my x is 1. So remember, your final answer, though, always has to be an xy point. So make sure that you go back up and you write 1, 2, because that's my xy point. Okay, on this next one, we're going to take it one step more difficult. So let's first look at this. So let's see, we have 7x and 2x. Those definitely don't become 0. And then we have 3y and 5y. Again, those definitely do not add to 0. So I have to think, how can I get these to add to 0? So first I want to decide, I need to pick which one do I want to cancel. Maybe I want to do the x's, maybe I want to do the y's. However, there's no way to just multiply 7 by something to get it to be a negative 2 to cancel. And there's nothing I can multiply 2 by to get it to be a negative 7. And same thing for the 3 and the 5. So this means that I'm going to have to multiply both equations. So for my 7 and my 2, I could get these both to be 14. I could make the top one maybe negative 14 and the bottom one positive 14. I could do the y's, and I could say I want to make the top one like positive 15, the bottom one negative 15. There's lots of different ways you can go about this as long as you're finding something to cancel. So for the sake of this one, let's do the x's. And I'm going to make the top one my negative 14. So I'm going to say negative 2, and I'm going to make the bottom one 7. Now you might be wondering, why did I pick these numbers? Why did I choose 14? So it doesn't really matter what number you get to. Like maybe I wanted to get them both to be like 28 or something. I could do that just as long as they are like the same, but opposite, obviously. So one's positive and one's negative. If that confuses you, I would just use the numbers they give you. So if you see here, I have 7x at the top. Well, I'm just going to multiply my bottom one by 7. And then I have 2x down here. So I'm just going to multiply my top one by 2. And then I know that they're going to multiply to be the same thing. Just make sure, though, that one of them is positive and one of them is negative if it's not already that way. Okay, so this will give me, start with my first equation. Remember, you have to distribute to all of these. Negative 14x minus 6y equals 24. And then my next one, positive 14x plus 35y equals 266. So now if I look, I have a negative 14x and a positive 14x. Those do become 0. So I know I'm on the right track here. So I'm going to add my y's together to get 29y equals 290. Divide by 29. And my y is 10. So again, I have my first one. I don't have the second one yet. So I'm going to take this and I'm going to plug it in to one of my equations. And I'm just going to do the top one. So I have 7x plus 3y equals negative 12. So I'm going to take this 10 and put it right here. So 7x plus 3 times 10 equals negative 12. And then solve down for x. You should get that x is negative 6. So my final answer is negative 6, comma 10. Okay, we have 2 more here and then 2 word problems. Okay, so if you need to reference back to these steps at the top, you can. So I'm going to decide, can I cancel a variable? So looking at this one right here, 6 and 12 do not become 0. 2 and 4 do not become 0. So I need to choose one to cancel. This time, let's choose the y's. So if I want these to cancel, I need to somehow get this to be a negative 4. So that way I have 4 plus a negative 4, so I get 0. So to get this to negative 4, I need to multiply this whole thing by negative 2. So that gives me negative 12x minus 4y equals negative 20. And then I'll rewrite my second equation. Now, you might notice here that my x's are actually going to cancel also. So those become 0, and these become 0. So that means I have nothing left over here. I just have 0. 0 equals negative 20 and 50 become 30. Well, does 0 equal 30? No. So this is a no solution. You can probably guess what our next one is going to be. We're still going to walk through it. So my x's don't cancel, my y's don't cancel. Let's say I want to cancel my x's. So if I want to cancel this with this up here, I'm going to have to get it to be a negative 18. So the only way to get that is if this is multiplied by negative 6. So then I have negative 18x minus 24y equals, negative 60. I'm going to rewrite my top equation right below that. So here I have these x's become 0. My y's also become 0. So on this side I have 0 equals. Now negative 60 plus 60 is also 0. Does 0 equal 0? Yes, so this is an infinite solution.